Okay, so let's start from the basics, because now about 1 hour we're going to spend upon the different security components, and that will finish our series of this introductory sessions. This is a fourth session in the row, as you all have been witnessing. Uh, so before we start to deploy the cybersecurity controls, we need to understand from this hand uh, made drawing. Okay, there are two parts in this whiteboard. So let's look at firstly the lower part. Okay, I would solicit everybody to mute yourself. Thank you. So we're going to discuss that how a typical very small business enterprise looks like. It will have some client. I'm still hearing noises here. Why don't you please mute? Somebody LS4505, maybe on the, yeah, I have muted now. Okay, so let's look at this diagram, and you can very easily figure out that there are some Windows client machines, there are some Linux client machines, and these machines will have authentication through the Windows AD or any other LDAP. We all know that yes, user credentials require the login, and once they log into the system, they are part of the internal infrastructure, and we're going to deal with this authentication part again. Then, as we have understood in the previous sessions, that in the orange color on the left side, you can see there is a VMware infrastructure which has been shown. So let's assume these are some 5-6 physical hardware level server compute devices that have been tagged together into a single rack, and VMware application of ESXi is running on the top of it to virtualize this physical grid into multiple virtual servers or multiple virtual machines, okay, which are called as VMs. And that is as good as you run your VM on the local desktop or a laptop. So this is one grid, that orange color grid of servers, which is going to host the servers plus applications. Sorry, you will hear some voice because I had to have some tea. Then you will see in the bottom there is a Wi-Fi hotspot shown, and on the Wi-Fi, which is F device, shown in the bottom left. If you look at that it is being shown to have a Wi-Fi connectivity being offered to laptops, to the mobile machines which come in the organization. And then all of these with those black lines are connecting to a layer 2 switch, which is represented by E element. And then this goes to the router, and this router is then connecting to a wavelength division multiplex or the MPLS modem, and taking this infrastructure to the internet. So this is a very simple north-south interconnectivity which will happen from any client A, B, C towards the internet, or from the internet towards the application servers shown on the D, or through the Wi-Fi it will go to internet, and so on and so forth. So these are the basic application flows you would see in this kind of a business setup. Then on the internet, we are showing three different applications. One is a DNS server. So with continuing with our previous examples, we all know that when a Windows or a Linux or any other client will go to internet, it would need a access to DNS server to get the resolution of the host name or to IP address. And then there is my bank server. So my bank, let's say we all are employees of this organization, and our bank is having a web server from where we're going to do internet banking, and that web server is called as www.abcbank.com. And then obviously we will all be exchanging mails internally between us or externally with the external world. In either case, we are going to use the my mail server, which is being shown on the top of that. Apart from that, there is one laptop employee who, in the current times of, let's say, work from home, who is accessing the applications inside our office. So they need to access the VMware ESX server. So some of us are using a VPN, IPsec VPN or SSL VPN. Don't worry about this. You will be seeing all this IPsec VPN, SSL VPN again coming in the next few slides. So on the laptop, they will work from home and they will be connecting towards the setup which is there posted on the left side of the screen. So this is exactly a business scenario. Okay. Now, in this entire scenario, we have made the business applications and business traffic to flow across different elements. Now, when this happens on the wire, what happens on the wire? On the wire moves the packets of data. And each packet of data typically has two primary components. One is shown on the top. You are seeing one packet being shown. So there is one thing called as header, and then there is another thing called as a data payload. So these are fields inside the packet, and in the source, in the header, what is defined, what is a source IP, who has started this packet, where this packet has to go is being captured in the destination IP. What is the protocol this packet is being meant for? Is it a TCP packet or any other protocol which is at the layer 4 of OSI? Then something which is called as a service port is what exactly is also being referred as a source and a destination port combination. What is this port? This port is basically a identifier for every application hosted on a TCP IP stack. So for example, port number 2021 is used for file transfer protocol. So when any file transfer server, FTP server you host in any organization, you get to see a port number 2021 being by default activated on that server to start receiving the such packets. Similar way, if it is a web server, then port number 80. If it is a if it is SSL server, then port number 443, and so on and so forth. So source port is from where the client will initiate the traffic. So that is a dynamically issued number. And the destination port is a fixed number assigned by that particular application that is running on the server side of the compute. So this is how a packet header looks like. And then you are seeing some shaded area. Those are the fields which are right now not to be interested in our discussion. There are, because there are a lot of other fields which are there, which we are seeing in the different attributes of interconnectivity. Some of those bits are like, which are used as the flags for prioritizing the traffic. Though it's shaded, but I'm still explaining you guys to understand this. So prioritizing a traffic means a traffic which is carrying a voice message has to be given a higher priority than a traffic carrying a mail, because if the traffic of the voice does not reach on time, or is there is a delay, then you will see a skewed voice. You might have also noticed on Zoom sessions sometime or the other, my voice or other experience with the Zoom, you would see that the voice get sometimes clipped, or just like a very different kind of a flat jitter voice comes in between, because that moment the voice packet has delayed in getting into the server side or the client side. So this is how those prioritizing bits, etc., are part of the header itself. But we are ignoring them because they don't have much significance from a security point of view. And then you have a real data payload, which is carrying a real message. In an analogy, who have not been seeing or who are seeing this for the first time, I'll quickly move from here. We all have seen a physical letter. We put that into an envelope. Envelope has a to and from address. So similar way, you realize that whatever are the real contents of the message, they are written on the paper A4 sheet, which has been folded together and have been put up in the envelope. Envelope carries only the header information, the message of taking that envelope from where to where. So this is how this packet's job is. Okay. So we'll have to start from somewhere. This is a very basic thing which we have put in. Looking from now security point of view, we have to offer the security to the header so that wrong packets do not reach me and my packets doesn't go at the wrong place. So this is a key objective of the access control. So when you are doing a security applied on the header, it primarily becomes a access control methodology, which means the security gets classified as a access security controls. Then if you are authorized, if the envelope is authorized to travel out of my network or reaches my network, imagine if somebody manipulates that, or if somebody adds a different envelope, different packet in that, or if he modifies or tears that message, in between. So all those are the variety of risks that can happen to this zeros and ones bytes which are there in the data payload, and we need to ensure their security. That's why the security gets classified, called as deep packet inspection, which means we are going to inspect the packet for each of those combinations of zeros and ones, and the different technologies that do the job of an access control are like firewall, like URL filtering, like authentication security controls, because they work on the header security. They decided on the base of source destination pairing, or source or destination alone, which way you would like to allow them. However, deep packet inspection controls are like IPS, antivirus, anti-bot, content filtering, DLP, and sandboxing. All of these we are going to demystify in the next few slides. So these technologies, they work on the packet data. So anybody who is authorized as a header may still become a problem by doing something wrong in the data payload, and that's what we need to work on. So for example, any intrusion that happens on port number through port number 80 or HTTP traffic, it means HTTP is a allowed traffic in my organization, but the hackers have used the allowed access control methodology or a policy to play with the data codes. And looking at, by deploying a header security will not ensure that you will be able to get a data assurance or data security. So this is why the security is either header security or the payload security. Header security is typically classifies itself as access controls, and the data security in this case context is called as a deep packet inspections. Apart from that, all these devices which are like router or a Wi-Fi hotspot or a VMware or a LDAP server, it will have the administrators who will manage them. So we have to take care of their having access to these devices so that their actions, first of all, they are authenticated correctly. Second, their actions are controlled. And thirdly, whatever actions are allowed to them, they get recorded. So this creates a stack of solutions called as authentication, authorization, and accounting, or AAA security. So that's basically for the administrators of these devices. So these are the three different types of security controls which we are going to work and talk about looking at this diagram, and we will evolve our understanding. So let's look at what is you are seeing on the the header on the top. Imagine the data has to flow from the machine 192.168.10.15. It has to go to something called as 34.107.99.85, and it is using a TCP as a layer 4 protocol. It is sourced from any source port of 1095 some number, and then the destination is going to SSL because it's a HTTPS packet, so it has to go for 443 port number. Okay, so all of you who are not aware about this 443, what is a port, please do Google search to find out after this session. But for the sake of this understanding, just imagine that 192.168.10.15 is like a source house. 34.107.99.85 is a destination house. Okay, when I get out of the house, I need some door or window or some kind of a outlet to go out. So let's say that outlet is also numbered, because each house will have some windows, some doors to get out or in. Okay, so that door number is 10995. Then when I reach the destination, now destination has written that I am a courier boy, so all courier boys will only enter via gate number 443, in this house. So that's what it means. So when I am entering a house number 34.107.99.85, it has been administratively written that since you are a courier boy, so you need to carry this packet only entering through 443, gate number 443. Then what I am going to deliver, I am going to deliver some packet. This packet will send me back something in a response. So when I'm starting back, again, I am a courier boy, so I will have to get out from 443. So this means the source port now, looking at that gate, will be same gate from where I entered. I will go out from that port. When I come back home or at my home location using the same outlet from where I exited, because this is how the transaction will be completed. So this is a return packet and onward packet which has been shown just in this Excel graph template of what exactly when you see a header and a uh, data payloads. What is required here? The first level of access control required for this is that these packets will continue to move freely. Now imagine this as a network situation now. We'll forget this courier example. That was just to explain you in case you didn't understand what a source and a destination port is. Now we know that all applications will have a fixed destination ports. Okay, so SSL will have 443, HTTP will have 80, FTP will have 21 and 20. Similarly, if it's a mail system will have 143 if it is IMAP, or 110 if it is a POP3, so on and so forth. So all these are these ports which are fixed on the service side. These are also called as the servicing ports because these are on the server side ports. The client port, which is 10995, these are dynamically added or dynamically started the moment I start a new connection. Now header ends up to these fields, and then this is the payload. Payload is the real data which is moving on the wire in the part of the packet itself. And when we look at this, here comes now what are those security controls that you can provide. Generation 1 security controls are the ones which were seen from 1997 to 2003. That's typically a generation 1 of security controls. Generation 2, the security controls which have been into existence from 2002 to 2010, typically. Generation 3, 2010 to 2018. Imagine these generation definitions are as per our experience. It does not mean that every other third party would agree for these numbers of years. but most experienced people with two decades of experience will always broadly put you into these generations like this only. So maybe some plus minus 1 year here or there, but you will more or less will see this is what has been there. Now let's look at what are the kind of header controls which we have seen. And let me tell you, when we are seeing header, this time I have broken the header into further two parts: header access control and header as extended authentication. Okay, so bear with me. This is all part of the header security itself. So let's come to the first row. Okay, so I'll again explain that we are going to see there are four columns here. In the column number 1, we are seeing control area of security enforcement. In the column 1, 2, and 3, we are going to show you different generation security controls that were introduced in that era, or the enterprises started to believe and start picking up those solutions. Might be they were introduced somewhere here or there, but you will see that in these years, you see the proliferation for these security controls. Okay. And classification wise, I have just brought it into generation 1, 2, and 3 broadly up to 2018. Okay. And on the rows side, we are going to see three different rows. So far, we have understood header and payload only, but header I have further categorized into a subcategory: extended authentication. Okay. Now let's look at the first row. Once I'll start speaking, maybe all of you who have not understood this, you will start getting a glimpse or understanding of what exactly is there on this slide. Okay. So when we are talking about a header security or a access control security, in generation 1, firewalls and anti-DDoS is what was very commonly started to be part of the security infrastructure by most customers. Though the firewall was officially launched in 1994, but by the time it became very prevalent, proliferated in the market, it was way back in 1997. And they were continuously the first objective which customers were investing until almost 2003. Now, what happened after 2003? Does that mean the customer stopped investing into firewalls? No. Firewalls became a part and parcel of the security strategy, which means even if I am talking in generation 2, when I was visiting customers in 2003-4, they all were more or less having firewalls. They were talking about the newer security solutions at that time. So that's what it means in this generation. When I started talking and meeting customers in 2010-11, does that mean they stopped talking about firewalls? No, they did not. Firewall was a given. It was asking for more features, additional security. So what does it mean? That whenever is as a consultant talking to customers in generation 3 era, by default generation 1 and 2 were part of the security solution. If not in existence, but then if I was giving that solution, it was by default assumed that generation 1 and 2 will be part of my solution strategy, or they will be part of my audit strategy, and I will validate wherever the gaps are so that they get covered along with the generation 3 tools which are to be bought. Okay. So now let's look at from a header point of view. What exactly the header access control solutions which were introduced in generation 1 or being adopted in generation 1 were firewalls and anti-DDoS. We're going to delve on each one of them subsequent slides. Just here, this is for the messaging. Generation 2, in the era of 2002 to 2010, people started asking for further beyond access control for a packet which is based on IP address alone. They started asking for URL filtering, which means I want to block www.email.com because I don't want people to go to their public emails sitting in my office. That was the objective. I don't want them to go to www.news.com. I don't want them to go to my sitting in my office using my internet pipe to go to their watching the news. So this was the era when the URL filtering started to come into being. Mail security became very popular in this era because spam mails, which is now part and parcel of your solution, you don't even ask for that. I need an anti-spam because it's by default given to you. But in 2002, the situation was not like that. People were wanting that which mails from which domains will come and not come. I will not be sending mails to these unsolicited domains. So that were part of the mail security solution. So that's how, because in the mail, so now this header has started going beyond the IP and the protocol alone, so that's how, but still staying at the header level. Then people started telling in generation 3 that I don't want Facebook, I don't want Yahoo. Now Yahoo is not just a single URL, it's a heap of URLs, it's a behind the scene, it calls multiple other URLs. Okay, so that's what is called as a domain security. And also in era of 2010 to 12, we started seeing huge DDoS attacks. Huge DDoS attacks have happened between 2010 onwards. So you would see why, because in 2010 there was a very active hacking group called Anonymous which came, and it has virtually brought down almost entire banks in 2010 end in United States. And for doing this, they were dependent on the DDoS through DNS infrastructure. The DNS which resolves a fully qualified domain name to IP address. So in 2010 to 18, people have started building the secured DNSs. Okay. Also, the users in the browsing space in sitting in my organizations, they were being tricked to the malicious websites, on the wrong sites, which were changing their domain name so fast. So that's how the secure DNS, SDNS plus domain security as a whole was being the requirement from a header access control security solutions point of view. Now coming to the second part of the header security, which is the extended authentication. So authenticators are being used from many years. Today we all know that whenever we buy a new Android or iPhone, we can have a face recognition to get into the phone, or we can show our thumb fingerprint to get into this, or it can take my iris data and can allow me to get inside the phone, or there is a pattern which I will play with the finger. All these are the authenticators we are now very uh, used to, because we have seen it on our phones. But in 2000 era or 98 99 era, we had different kinds of authenticators which were called as two-factor authentications, which means you will have a password substantiated with some pin number, okay, a mathematical number, and password and a pin number will combine together to give a two-factor combined authentication. So why was this? So that if somebody comes to know my password, he or she may not have my PIN number. So therefore, it is not so easy for them to get into my login. Similarly, if you see that this is for the users who are interacting on the wire. Apart from that, there are administrators which were being given the similar technology, because they were logging with the administrator access. And in the administrative access, there can be a possibility that a static password of an administrator might be stolen. So password has to be substantiated with the second factor. So extended authentication became very popular for both the users who are logging in to access the applications, or the administrators who are logging into for the administrative purposes. That was a ask in the generation 1. So people were only asking for two-factor authentication solutions. Then came generation 2. In the generation 2, we started to see the distinction between the people who are getting inside the network, or are the users who are consuming the applications. And we started to see a distinction from the administrators who are accessing the security devices or routers or servers as the administrators. So now you see two parts of the authentication: internal users, comma, TechAX. So TechAX was a new way of authenticating the administrators and keeping their passwords in some centralized space, plus also AAA, as I told you in the previous slide, specifically not only takes care of authentication as a solution, but also authorizing, which means which administrative task can be done by person A, which administrative task will be done by person B, which set of administrator tasks will be done by super admin called administrator C. So that's called as authorization. And each one of these, administrator A, B, or C, whenever they will do any action on any network security or a server compute device, that will get recorded for the future reference of audit. So that's why it is AAA. But AAA was firstly launched in the market in different formats, and TACACS was one of the very popular way of making the administrators access possible through that framework. So if you see with the comma, two types of solutions started to happen. So people started to have more policies. So we saw Microsoft launching something called as AD, Microsoft AD. Okay, before AD was Windows NT. So all these technologies were there launched because they wanted all the users in the organizations to start having a common user policies or group user policies. Now we all very commonly say Microsoft AD de do and all that. Okay, but in 2002, AD was a very big subject, which has now slowly and gradually has become very common thing. Okay, so that's where the internal user policies were expected. And then, and the administrator level, the AAA solutions were being adopted called TechAx. In the generation 3, we have gone further strong. TechAx is no more sufficient. People were asking more agile methods of recording data and administrative access, which is more granular. So that's why PIM and PAM, which is a very popular solution today, has come to the market between these era. And for the administrative purposes further, the access policies uh, to access the infrastructure of administration, people have started introducing to absolutely make their server compute, their networking devices, their application administrative accesses. Absolutely, they wanted to hide them from the direct access from the external world, while they all knew that these all application servers, etc., are sitting in somebody else's cloud infrastructure. So they need to give that access to their administrators, but their administrators will use the reverse proxy functions to get into these servers. Also, apart from, so this is on the administration side. Apart from that, now imagine that you are using the Salesforce application, or you are using, let's say, Google Mail sitting inside QS Office. But when you go out and you open a Salesforce or a Google application outside in your house from a desktop browser which you have at your house, how do I, as QoS, ensure that the same security which we have deployed at the QoS campus is applicable when you go and sit in your house? I will not be able to control that until and unless that I introduce a small reverse proxy application in your browser. That would mean that every time you will go towards Google Mail, or every time you will go towards Salesforce, which are two companies' business applications, you will be redirected back to QoS infrastructure by these two application vendors. So that's the other abstraction of reverse proxy which existed like that. It's a little complicated and a complex solution of today's time. I would leave that reverse proxy. You guys can do further research out of your interest. But I will move from here to the next subject, which is the data payload traffic. Okay. And for that reason, reverse proxies, you can watch for some current generation reverse proxy cloud companies. One of them happens to be very popular company from India. I've just forgotten their name. By the time I'll finish the session, I'll let you know, so that you can go and look into their solutions to understand how a reverse proxy works for the end users, not the administrative access. Okay. Then coming to data payload. Now this is very interesting. Data payload is a ever evolving expectation, and the security of data payload, sorry, is a ever evolving expectation. In the generation 1, we used to see two very interesting security controls that were offering a deep packet inspection. The first and the foremost was antivirus, and the second was intrusion detection system. Okay, mind you, until almost 2002 we did not have very popular technology of today called IPS. It was in its previous version or a previous abstraction called intrusion detection system. So it was only detecting at that time, it was not preventing. Only when in 2002 Cisco acquired a company called Okena, and they firstly introduced intrusion prevention at the desktop level or at the laptop or the end user level, is when the IPS has started to evolve. In way back around 2004-5, for the first time the organizations have started adopting the IPS at the north south level, not at the end compute alone level, at the north south level. Okay, so that's why you see in the generation 2 IPS being mentioned, while in generation 1 it was only intrusion detection systems. Then we have anti-malware solutions. So by generation 2, the virus was no more a atomic problem. Okay, multiple viruses used to exist together, or one virus was evolving itself in multiple ways to enter. So let's say a same virus will enter via email and also through a doc file. So such situations in which the virus codes exist in multiple forms, or they keep on evolving from one vector to another vector. So vector is basically the carrier. Okay, so vector carrier could be a mail, could be browsing, could be file transfer, and now with all these new generation apps, could be Android or Apple apps. All these vectors will have a common code of problem, and that's where it is no more a virus but a malware. Okay, but technically it might be same, but because it is different frameworks which are being there, so it would need different encoding, different replication technique, while the basic payload of the problem might be same. Okay, so that's where it is now defined as a malware. So we started to adopt the malware anti-malware solutions. Also, in this generation of solution adoption, we saw a lot of companies have started to realize that it is no more application or server which is being targeted or host which is being targeted. People are moving their objective of hacking to the real data. So they started stealing the data. Unless we reached generation 2 around 2004-5, data was not very critical. People were not worried too much about having lost their documents or Excel sheets until then. But then all of a sudden they started realizing the importance of those, not so specifically always the intellectual property, but similar elements which are part of your own company's business requirements. You are using and exchanging data with your customers, and so on and so forth. So virtually the data has become a very important asset in this era, and hence the data leak prevention DLP solutions became also equally important. Then we saw generation 3. In generation 3 came the next variants of malware. Now people started using the intermittent agents to launch my attack. So they used to infect the zombies, and then these zombies were being controlled by somebody outsider, and hence, because somebody else is controlling from outside, they could evolve the structure of an attack. They could move from one payload to another. They could move from one encoding to another if suppose an antivirus on that machine has detected them. So there were virtually these zombies were hidden and were not, or were dormant rather, and at the day of launching an attack, they were being activated or triggered. So such state of attack is called as advanced persistent attack. They started becoming very, very popular from 2010 onwards, because in 2010, you guys can write down, a very, very critical attack was launched against the nuclear power plant of Iran, that was called as a Stuxnet. STUX, X for Xerox, Stuxnet. Okay, so Stuxnet in 2010 was the one of the very, very critical attacks which actually evolved the anti-malware terminology to something called as APT, Advanced Persistent Threat. So people from 2010 have started to ask for APT solutions or anti-APT solutions, which are primarily driven by anti-bot. So those zombies are called bots, and the person or the bridgehead who controls these bots is called as command and control. He is their master who sits outside. He creates the bots in the different part of the world, and these bots, they further launch the attack on the desired host. All this is continue to persist because command and control can actually evolve this attack pattern to any new pattern or any new payload. That's why it is called as persistent. So advanced and persistent, that's are the two terms, advanced persistent threats. But also, which is important in anti-APT, in the APT as an attack, is to understand that it is a combination sometimes of a virus, malware, or a bot put together. Okay. Hence, APT is nothing but, you can say that, advanced malware. Also, that's another easy language sometimes if you don't understand. Last but not the least, in the era of 2010 and 18, something which has become very popular, that if you look out for these solutions, which is antivirus, IDS, intrusion prevention, anti-malware, leaving aside DLP solution, but if you look at the most of these anti-access solutions, you would see that these solutions work by capability by virtue of signatures. So they understand a pattern or a method or a code which is being used to launch an attack, and they create an antidote of that. And while doing so, that signature database keeps on increasing. Now imagine if somebody launches a new pattern or a new attack or a new code. In such case, this kind of a code still do not have a anti-X technology right now available, or a anti-X signature right now available. So how do you recognize this? So this category of such attacks, which are not seen anywhere else so far, so they do not have an answer or a solution, they are called as a day zero problem. Now, day zero problem is also like a COVID-19 right now. Okay, so since on the day it started itself, nobody knew that how genetics of this code works. Okay, whether it's a RNA which gets replicated to become a DNA, or it's combined itself to a existing protein synthesis and then start laying the eggs. Nobody knew this. Now people have started to only demystify that. Still, it's so complex that the solution which is going to be antidote to it is going to take some more time. Similar way, in the technology, the sandbox are dealing with those D0 problem, and they try to understand whether it's just like a script, or it's a egg management technology which is different, or encoding which has been different. So all those various ways in which the virus possibly or a bot can spread itself, these technologies on the day zero, when nobody else knows them, some tool has to understand and prevent them from harming my infrastructure. So this is what exactly has happened in generation 1, 2, and 3 of solutions. This is a very important slide. I would give you 2-3 minutes to write down your own notes from this slide for your Google research. Also, I will be hosting this. This session is getting recorded, so it will be hosted for all of you if you have missed or you would like to rehear that. Okay, so you will get a chance to do that. Just make some 1 or 2 quick notes if you would like to, and then we'll move to the next slide. Okay, so now let's understand what are firewalls. So as I said, we'll cover some of the important elements in this. I'll not be covering all, but we'll be covering in next 20-25 minutes some of those important elements in this entire spectrum of solutions which we have shown. So let's say firewalls. Okay, so the firewalls deploy the access control based on the IP packet header. When the firewall is inserted in the north and south traffic flow to inspect the packets, it will enforce the access control on the basis of the header, okay, which is to be inspected for the packet. In order to deliver this, something needs to be configured. Okay, to this to happen, something has to be configured. Now what is that? Look at this. Okay, so by default you will see something. This is a very basic rudimentary way of me having shown you that how the policy of the firewall, let it do what it is being asked to do. Okay, so by default it will always have a deny implicitly in the bottom. Even if it is not defined, by default all firewalls, when they are inserted on the wire, they bring a deny all traffic rule. Then you will start to create the rules on the top of it. On the top of implicit rule, you start creating these rules. So now look at this. For example, you can create 192.168.10.19 msupdates.com. So now this is a destination, some domain name, okay, of Microsoft Update Server. And then what service should be allowed? Microsoft SUS, Microsoft Update Service, which is using TCP protocol and that door number or the port number 8530 and 31, sorry. And the action is allow, correct? Because you want to allow them. Then I want to tell that my entire LAN can go to internet for what all? For web and SSL traffic. Okay, so web I have already told you, it uses TCP protocol and the door or the port number 80. SSL, the TCP and 443, it should allow. Then from the internet, I have hosted my own mail server inside my office. So people should be able to come to my mail server. Now the send mail is called as SMTP protocol and receive mail typically is IMAP. Okay, so those are the different port numbers. Port number 25 is a non-encrypted mail. 465 is an encrypted mail when you are sending an encrypted mail. IMAP is port number 143 when you are receiving the mail which is not encrypted. 993 if you are receiving, for example. So these are default numbers. Okay, they might change somewhere in the organization to organization, but for the simplicity's purpose, this is how. And you will put an allow action, which means other than these three application flows, nothing else is allowed. Nothing else on this firewall. Okay. Now another important thing. This is a stateful firewall which was introduced to market by Checkpoint Software Technologies, with which we are 4-star partner in the country for almost 4 years now, and we have been partners to them for last 7 years as a company. Couple of us are ex-Checkpoint folks also, like me and Ashok. So put together, what Checkpoint did, they launched a firewall in the market which is called as stateful firewall. What a stateful firewall does, if you see, you have only created a request packet rule, which means from a source I am going to Microsoft updates, but there will be a return packet also, correct? which we have shown in the beginning, that yes, there will be a return packet. A beautiful thing which a stateful firewall does is that it always approximates or assumes what is going to be the reverse packet, and you are not required to create a reverse rule. This is the beauty of this rule base, that okay, you only create in which direction you want to move as a start packet. Return will automatically will be introduced or taken care by the firewall. So this is a beautiful part of a stateful firewall, okay, which was introduced by Checkpoint, and that's why Checkpoint is still the leader today because of this, because this is a patented technology to them. If anybody, even Cisco, Palo Alto, or Fortinet, who is using this technology, they are paying royalty to Checkpoint for this. Then we have now the newer abstractions. We all know that, just give me a minute. We all know that the complexity is not only at the application level where people are using Microsoft update service, or they are going to internet for web or browsing through SSL, or they are just sending mails and receiving mails, but they are smartly accessing different applications today, which are more complex, like YouTube, LinkedIn, Facebook, O365, GitHub, MSN, LinkedIn Premium. You know, LinkedIn Premium is a premium function inside LinkedIn and an application, for example. So these newer applications, they are all on the port number 80 or 443 as a port. So how do I, looking at the first table, be able to enforce security for this? It is very difficult. So there is another giant now, which very big competition to Checkpoint, called Palo Alto Networks. They introduced a app ID model, app_ID model for it. So what these firewalls do is, they will understand from the packet itself, the first few bytes in the payload, that this is asking for YouTube. This is looking like a LinkedIn. This is going to something which is basically taking into the premium mode of application of LinkedIn. So all this is basically introduced by Palo Alto, and also now being in action by Checkpoint. So Checkpoint also does both. Okay, so they combine this policy. So green color looking policy is basically a TCP port based policy, which is for stateful packet inspection. And then the second part is basically a app ID based policy. So if you look at this, what we have seen in this table, let's demystify. My LAN users, destination is internet. What I am allowing all LAN users, go to YouTube, LinkedIn, Facebook, O365, that is Office 365, and allowing them to use these applications. Then there are developers in my company who need to go to GitHub, and also they need to use a Microsoft network. So imagine all these developers are by default the part of my LAN users also, correct? Because they are, my LAN users is a superset. So my developers are my LAN users also. So by that part of the first rule, they will be allowed to go to all that. But my developers is a smaller group who will also go to GitHub and MSN. But not all LAN users will be able to go. Then my HR and marketing will have a LinkedIn premium access. So premium is one small widget inside LinkedIn. So I don't want everybody to start going to a premium. Lastly, I am a small fintech company, imagine, and I have some internet banking being hosted at my website inside my data center. So I will allow, and I have created a iBank app, which is for both Android as well as iOS, a common iBank app. So this iBank app should be able to come from outside as internet source, and should be able to reach to my internet banking server as a host. And the app ID is iBank. So this is my own, and I will say allow. And this will also, whatever you will allow, only that is allowed, rest all will be blocked. This is how these firewalls, they work. Okay. So we have two types of firewalls, stateful only or the app ID based. So as QoS, when we are working with Checkpoint, we have both, because they have both now started supporting. Palo Alto was giving a real run for their money, so they have also introduced this function of doing a app based security, which is called as application control based security. Okay, so this is about firewalls. Then we need to have a deep packet inspection. In the deep packet inspection, as I told in the beginning, that there are two primary solutions which were introduced in generation 1 and still being very popular today. One is the antivirus. Antivirus is one of the oldest security solution. Even before firewalls, it was being used. Firewalls were active when the network started to go. But antivirus, Dr. Solomon, which is now Symantec, was one of the very few antiviruses which were in existence even in 1985, 87, 1990, to actually take care of the antivirus on my machines. No matter whether that days my machine was DOS based machine, disk operating system, or Microsoft 93. I forgot what was that called as. Before Microsoft 95, there was some Microsoft 93, where we used to have those antiviruses. Now, viruses will either target the endpoint compute, which means the machine, or they will target the network where multiple machines are connected together. So they will launch attacks so that network become flooded. Okay, or they will target the end user through web content access, mail flows, or the file transfer. So these are the three main things which a user does even today. Either is browsing or she is browsing, or they are sending mails or receiving mails, or they are moving files from their machine to a external device. So these are the most three common functions which the users do. And these viruses, they target through these channels. Now, the viruses typically are either zoo or in wild. So these are our terms which are being used. So in zoo means the viruses which are not very aggressive. They have been existent in past. You just need to have a very basic security to take care of them, because they will still be there. So if you don't do a basic security, they can attack and harm you. Similarly, in the wild. Okay. So for example, let's say a dengue virus right now is in the zoo. It's not harming too much. But the COVID virus 19 is in the wild now. It's rampant. So similarly, in the computer, you see these kind of viruses like that. Also, the viruses have polymorphic and metamorphic variants. Very important to know. So viruses which were in the generation 1 were very atomic viruses. But in generation 2 onwards, they started becoming polymorphic or metamorphic. Metamorphic means I will have, let's say a virus is a code of 1 byte, 11000011, let's say something like that. Now, antivirus will have a signature to detect this code and will start blocking it. So this guy will change 1 bit position here and there. Okay, so that the antivirus doesn't know now. Now antivirus will find this and treat this as a new byte code. When it sees as a new byte code, it will morph again to a next stage, okay, or a next type. So that's called as a polymorphic. Means it is going to morph itself into variety of new shapes. Sorry if I used earlier metamorphic. So this is polymorphic. Okay, so when a same code present itself with a different byte function, so that's the polymorphic characteristics. Metamorphic is when a virus evolves from one stage to another. Metamorphosis is again a biological term, which is nothing but an evolution of a caterpillar like to a butterfly, for example. So it's use stages. Same way, the virus will be in one shape or one type in the stage 1, but by the time it reaches to stage 6 or 7, it will become different. So it will morph into different stages. So polymorphic and metamorphic characteristics of viruses, some may show both, okay, some may show one out of these two characteristics, makes the detection and prevention much more complex and difficult. Then antiviruses, now based on these characteristics or issues of viruses, your antivirus has to be aligned to these goals, okay. So antiviruses have therefore been keep on evolving with every generation, and hence you see a very important piece of their solution strategy for cybersecurity even till today. It looks at the issue inside the data payload once the connection has been authorized and authenticated. So it's like a payload inspection. It's not the header inspection. Antiviruses do not work on headers. They work on inside the payload. If somebody has introduced a malicious code or modified or mutated the existing code. Typical antivirus solutions work on signature and patterns matching. So as I have been explaining. But we also today have some next generation antiviruses. So you can write down some names, you can research those. Tanium, TANIUM is the next generation antivirus. Carbon Black. Then you have Sentinel-1. Sentinel-1 is a single word. SENTINEL-ONE1. So these are next generation viruses, antivirus solutions, sorry. So what are these next generation? One of the most popular is Tanium, TANIUM. Okay. So these solutions, what they are offering today, they are saying that we can take care of, no need for you to be going a signature based antiviruses. So they promote themselves through this philosophy. While this is not 100% correct. Okay. Most organizations can, because this polymorphic and metamorphic characteristics make the journey of virus updates so fast that every now and then you are now updating your antivirus engine to avoid this complexity or this catch the flag kind of race. It is important that you have a possibly another important solution which does not require you to go in the race of signatures. That is true, but that doesn't mean that you don't need a signature based solution, because signature based solutions are very, very, very fast, because they just do a immediate pattern matching, and hence they're fast, they're less intensive on the endpoint device, so they make their existence still relevant. Okay. Apart from that, the organizations are substantiating themselves with next generation antivirus solutions. So what does it mean? Eventually what I'm trying to say is that if you go to a bank, they will definitely have both. They will have, let's say, a McAfee antivirus and a next generation antivirus from FireEye, or they will have a McAfee antivirus and a Tanium and next generation antivirus, or they will have a Trend Micro antivirus and they will have a CrowdStrike next generation antivirus. So all these things you will see in your customer space. Then we have another category of solutions which are intrusion detection systems / intrusion prevention systems. Mind you, I have not captured that. I will come back to antivirus. So when we are looking at the antivirus, because if you see, the virus has 3 different places to compromise. One is the end compute itself, the second is the network, the third is the flows inside the network. Okay. So we will have 3 different deployment points for antiviruses. One is on the endpoint, both the client side and the server side. Second, we will require some device to understand the network behaviors, network flows. So there is a network antiviruses which are deployed as appliances inside the network. And then we have third category of solutions which are which get embedded with the mail flow or a web flow or a file transfer flow. Okay, so whenever you are using a HTTP proxy or HTTP access, you will be redirected towards the antivirus for the inspection of the traffic. This is the third deployment point. So when we are putting a third deployment point, it will further have three different objectives. One is to secure web, second is to secure mail, and third is to secure file transfers. Now, in the file transfers, we are now further getting further fine tuned. There are fileless viruses which are using only JavaScript. So you need a protection on the JavaScript framework, so on and so forth. This is a keep on evolving deployment points. But typically, if you see, either you will call it as an endpoint virus, antivirus, or a network antivirus, or you will be using it on the respective application flow which the users are commonly accessing. Now, moving from antivirus to IDS/IPS technology, intrusion detection is a generation 1 solution, while intrusion prevention is from generation 2 onwards. They both work for deep packet inspection while they are modeling the traffic or threat, but intrusion detection is like camera surveillance. Okay, which means you have put in, until and unless there is a supported response mechanism to respond and mitigate the threat, the camera itself is not capable to stop it. So you will need an intrusion prevention who will prevent it from that level. Then we are, while in antivirus, most typically the user activity is the objective, where the user is a starting point of communication and gets on and tries to bring in some wrong things into my infrastructure. So the starting point in the viruses is the user activity. However, in the intrusion, it is not the starting point, it is the end point. So they target the servers. So if a user sitting outside is targeting the server which is hosted inside the data center, this is typically the intrusion. So intrusion and viruses technically might be having a similar way to propagate, similar way to create a problem, but the way they're introduced in the network are different. Okay, so for example, for a bank who does not have the browsing users inside their data center, the risk of virus is much less than the risk of intrusions, because they are hosting the application and servers inside their data center. However, the born in cloud company which is creating a toon content, and they are a cartoon company, they have all the developers and the browsers sitting inside their infrastructure, while all their content of where they are creating movies, cartoons, etc., is somewhere hosted in Amazon cloud. Now this company has to worry more about the viruses because the users are always browsing. So there are user activity which is starting from inside the network, while technically both intrusion and virus, they target a payload, and they target a payload by manipulating the payload, by infecting the payload. Okay, so typically when you are crafting an intrusion or you are crafting a attack, you would work more or less on the similar as a hacker, but you will target different deployment points. Okay, so intrusions move towards the host, while the virus is targeting the compute. Hosts are the serving computers. Okay, the servers are called hosts. That's a very typical term being used. And compute is basically the any form of compute, be it on the server side or on the client side. Now, having said that, why I have written compute does not mean that the servers are not at the risk of the virus. Okay, so another important distinction feature between viruses and intrusions is that the viruses, they show the characteristics of morphing. So they show both polymorphic characteristics as well as metamorphic characteristics. While intrusions, they don't generally have those characteristics. So any intrusion which is targeting a server compute, okay, or a host, and is showing metamorphic characteristics, will no more be classified as an intrusion but classified as a virus. So this is how, little difficult to assess if you are doing it and hearing it for the first time, but this is how, once you start working on these solutions and the consultancy role, you'll start understanding them more. Then the intrusion attacks will also try a lateral movement. So they will compromise a web application, and then they will try to move to a stage 2 by compromising a database. Then when they are compromising a database, they will use a different intrusion mechanism, which is basically not in line with the same with which they have compromised the web server. So that's where the metamorphic characteristics are different than multiple staging of the attacks. So stage 1 to stage 2 are two different types of attacks, okay, when they get combined together. So stage 1 was to target a web server, compromise it, and after we have hosted or planted ourselves or pivoted ourselves on the web server, now we will start compromising the the database server. So with the different techniques, different techniques and different tactics. So it will not morph itself into the second stage. It will require to be taken to the next stage. So that's also a little difference from moving from stage 1 to stage 2 of an intrusion, as opposed to morphing itself, by moving from one to another type of the stage. In the current times, the intrusions and viruses are combined together. So that's another interesting thing which is happening in these attacks, that the hackers, they combine intrusion in the stage 1, move to intrusion in the stage 2, but from stage 3 onwards, they launch a virus which has metamorphic characteristics. Okay, so this becomes an advanced persistent threat. APT is a combination of multiple technologies working together as being used by hackers to launch an attack. Last but not the least, also atomic and less compound intrusion attacks are protected by integrated IPS and firewall. Very interesting thing has started to happen, that as an industry, what we are seeing that uh, the more and more intrusions, if they become complex or they get compounded with the with the viruses together, slowly and gradually, what we will see, the extinction of the need for IPS. This is going to happen, and it's rather in last 2-3 years it has started to happen. You see less number of people asking for a dedicated IPS now. They either ask for anti-APT solution, which will have some characteristics of IPS as well as some characteristics of antivirus bundled together, and also a characteristic of anti-bot to become an anti-APT technology. Now, what will happen to the very stage 1 level of very simple level of intrusions? Who will protect us against them? So what has started to happen is that these firewall vendors, they have started to give and launch the integrated IPS, which means it will work along with the firewall, additional now payload security functions. So no more the firewall is called as just a access control device, but an access control device and an integrated IPS. Now, what such devices are called as? These are called as next generation firewalls. Okay. So from a historical point of view, while it was important for you guys to understand a firewall, it is equally important that when you go and sell a firewall today to a customer, he is no more interested in just giving a firewall which can take care of only access control. By default, they are expecting some degree of automatically doing a integrated IPS function with that, so that they do away with their need of buying a dedicated IPS. So virtually what is happening is that after few years, IPS will no more exist in the market. Either it will become a part of the antivirus completely, some functions of that, or it will become a part of a evolved requirement called anti-APT, or it is going to be the very atomic part or the less compound part of the intrusions will become a part of the firewall as an add-on solution to it. So this is called as an integrated IPS, also called as a next generation firewall. I believe this was quite a content. And any questions? Hello? Any questions, folks? Okay.
Hello.
Is it, yeah, is it going at a right pace?
Yes, sir. Sir, this is Anish.
Yeah, Anish.
Sir, can you just give me some example of polymorphic and metamorphic?
By real names,
Yeah.
okay, like spyware.a, spyware.b, spyware.c. You might see, antivirus is showing A, B, C, and then after they reach Z, they start saying AB, AC, AD. So they keep on coming with new changed code. Okay, so let's say if it was a combination of bits like 1, 2, 3, 4, 5, 6, 7, 8, I will scramble them and make it like 1, 2, 3, 7, 6, 8. So new virus, it's just like a new virus for a machine. Because my antivirus was only capable to decode 1, 2, 3, 4, 5, 6, 7, 8 written in this sequence. Then imagine now how many such changings I can do. I can change a digit place anywhere to anywhere. So in that means my virus will be called as virus on the day one. Then it will be called as virus.a, because the moment antivirus will have a signature to decode 1, 2, 3, 4, 5, 6, 7, 8 written in this way, I will change it, correct? I will make it 1, 2, 3, 6, 7, 8.
Yeah.
Okay.
Yes, sir.
So this way I will keep it 8 bits only, but I will keep on changing the place of these guys. Okay. And
Okay.
with an understanding that everywhere I will use only one, I will virtually have 8 factorial options. 8 into
Yes.
7 into 5 into 4 into 3 into 2 into 1, correct? That's the number of
Yes.
permutations I can make. You understand? With
Yes,
the
sir.
same, this way the viruses will have a permutation and combinations, because you can actually play with one digit here and there and can fool the antivirus. So every time you're changing this as a hacker, the antivirus has to actually create a new code to detect it, or a new signature to detect it. Okay.
Okay, sir.
So now let's move it. Let's move it now. This is polymorphic. So now let's move it to a metamorphic. Okay. So a metamorphic is basically a multi-stage virus. Okay. So what will happen? For example, the virus has uh, virus has a genetic material, or I would say virus has a material for another code. Okay. But when I will introduce it onto machine, it will connect itself, because when I've introduced, it's a JavaScript, let's say. Okay. It attaches itself with some Java program and gets launched. Okay.
Okay.
Now when it has got launched, what will it do is it will drop two more files inside my machine. Okay. So it will create two eggs, two files. Okay. Which will be dropped. Now what are these files? These files have a trigger written in them that on 27th March at 00 a.m. they should get active.
Just
Okay.
like, sir, CNC.
No, not CNC. CNC is somebody else from outside controlling. There is nobody outside controlling. No? This is like
Okay.
the JavaScript was capable to create new two files. When it
Okay.
gets attached to its program, it creates two files. And those two files were sitting inside my file system. They were not active. So which means nobody knows that they exist. Okay, but it has dropped it. They will get active only on that timer which has been put up into that. Okay. And when they will get active at that time as the files, they will attach themselves with a Microsoft Word whenever next time it will open. Okay.
Okay.
And if the Microsoft Word will have any known vulnerability with which this can attach itself, it will become, now my Word gets infected. So
Hmm.
it was launched as a Java error, okay, because there was a Java vulnerability in my machine through which I introduced this problem. But then it has evolved itself to now a Microsoft Word problem.
Okay.
Okay.
Yeah.
So now what will happen? At the first stage of the attack, I should have blocked it as a JavaScript. In the second stage of the attack, I should now block it as a antivirus of the protecting against the doc files. Understood? So this
Yes.
is how this becomes multi-morphic, multi-staged. And it's not that I might have taken an example of a JavaScript and a doc. It might so happen that it will be one JavaScript which is introduced, and then it will give a birth to another two JavaScripts. Okay. So this is it need not be like it will use a different vector. It can use still the same Java